the friction lab. The objectives of this lab are two. The first one is to investigate the difference between static and kinetic friction. And the second one is to calculate the static and kinetic coefficient of friction for a shoe sliding along a horizontal surface. The materials needed for this lab is a tennis shoe, 1000 gram weight, a spring scale in Newton and grams, a calculator, and 2 coloring pencils or highlighters. So in this picture is pretty much how the lab is conducted. Here we have a tennis shoe, a weight inserted in the tennis shoe, and a spring scale that is going to pull the shoe and mark the value of the force, the pulling force. So there are 3 contact surfaces that this lab is going to be conducted. One is the classroom floor. The second one is the classroom floor with a paper under the shoe. And the third one is the hallway concrete floor. So here we have a smooth surface, and you will make even smoother with the piece of paper between the shoe and the classroom floor, and a rough surface, which is the concrete floor. So in this lab, I already provided a shoe with a mass, 400 grams. And also I have provided the forces when you pull the shoe on those 3 different types of surface. Classroom floor with the paper under the shoe, and the sidewalk concrete. We have here the static friction force and the kinetic friction force. So the first one, when the shoe just starts sliding, and the second one is when it's sliding at constant speed. So let's take a look on how to complete this table. So the first thing you're going to do is you are going to complete column 1. You are going to add the mass of the shoe and the weight, which is 1000 grams. So we have 1400 grams. Now we are going to convert the grams to kilos by dividing this number by 1000. So now we have 1.4 kilograms. Now we are going to convert this mass in Newton, with like weight in Newton, which you are going to multiply by 9.8, which is acceleration of gravity, 9.8 meters per second square. So the product is 13.75 Newton. So this is our FG. Next, we are going to draw the free body diagram. So this free body diagram, we have 4 forces acting on the shoe. One is the weight force straight down, which is this number right here. The second one is the normal force, which is normal with the contact surface, making 90 degrees angle. So this force, because the system in equilibrium in this direction, so these Fg and Fn, they have the same value. And now on the horizontal direction, we have the spring scale that is pulling the shoe, and this is our apply force. And now we have the friction force, which is opposing the motion, and we are going to represent it by FF. So now we're going to take a look on this table. So the force on this scale that I'm going to read when I pull the shoe on the classroom floor that was provided to you is 10 newtons. Now when I add the paper under the shoe, my pull force is less, is 6 Newton. The pull force when this diagram is when the shoe just start the motion. And now on the concrete hallway, my pull force is 12 newtons. So since the system is considered in equilibrium, my Fn is equal Fg, which is 13.75 newton. My Ff is what I read on the scale, my Ff on the scale. And my coefficient of friction, the static one, that is required to start this motion is whatever I read on the scale, which is my Ff, divided by Fn, because that's the formula. Remember the triangle that I draw for you is mu is Ff over Fn. But Ff here is what you are reading on the scale. Now, what you are going to do, you are going to calculate the coefficient of static friction using this formula right here. So your scale for the classroom floor is reading 10 newtons. So you do 10 newtons divided by 13.75. So you're going to write your result here and should not have a unit because those units are canceled out. Same thing you do for classroom floor and for sidewalk. Okay, so now let's take a look on when the shoe is keep moving at constant speed. So you are sliding the shoe along those three different surfaces. Now you have the steady number showing on your scale, which is different from this one. This one, when you first start your motion, you have noticed that the indicator of the scale went all the way down and then came back to a lower number and kept constant. So now we are talking about this diagram. So here we are going to record the number that you read when you slid the shoe on the classroom floor was 8 newtons. That was constant, like moving constant. The same thing with the when you have the paper under the shoe, moving constant, the indicator was 4 newtons, and outside on the concrete hallway, 10 newtons. And likewise, this table is similar to this because you did not change the weight of the shoe. You did not change the mass. You did not change gravity. So the Fn and Fg, they are in equilibrium, and that's the value, 13.75, identical to this. Your friction force, the same thing that you are reading on the scale, and the coefficient of friction that you are going to calculate on this column 7 will be your scale, what you read on a scale, 8 divided by Fg, or Fn, which is the same. So 4 divided by 13.7, and 10 divided by 13.75, sorry. So you are going to have now, you have those two, column 5 and column 7, with your numbers that you need to draw a bar graph. So this bar graph should look like this. So what you're going to do is, once you calculate your coefficient of friction for each case, static and kinetic friction, you are going to draw on your vertical line the value of the coefficient of friction, and on the horizontal value you are going to um, raise your bar based on the number that you obtain on your calculation. So notice that here is for classroom floor, this is for the classroom floor plus the paper, and this is the sidewalk concrete. So as you notice, the one that is offering less friction is the one that you place the paper under the shoe, and with more friction is the sidewalk concrete. So you complete these, make colorful, and make very distinguish between the kinetic and the static coefficient of friction. Now for your conclusion, you need to search online the difference between static and kinetic friction and write some examples of coefficient of friction and compare the values so that I can accept it as a conclusion. So I hope this video help you to complete the lab table and the graph and also the conclusion.